Right. Where are we at? Where are we at? We're on the internet live. All right, fantastic. Boom. All right, starting SSH. SSHing in. And we've got a show. Okay. So, all right, we're going to jump right in. All right, so this is what we're doing here, right? So we're shooting to implement this command. Alice, please contribute recommended community standards and then to the project, right? Eventually, we'll make that into some, let's see, maybe. Oh, wait, this is not in. So here we are. What branch are we on? So we do a git status. All right, so we're on origin manifest. All right, so we do a git diff. What were we doing here? Okay, the locking, right? So this is what we were messing with last time. All right, yeah, I gave up on this. Okay, you know, I liked this code as debug code. Let's commit this and we can throw it out later. So df memory added operation debug print operation on lock acquisition. All right, so, and that was obviously not helpful because the thing is still there. So we need to go bisect it to figure out when that issue was introduced, and if it was introduced by if it was introduced by something we did recently within the manifest branch, we need to then just undo that, right? Just fix whatever we did. If it's a lingering issue which has been around for a while, then we're going to go back and grab the metrics implementation and the locking that was working there in the initial implementation of the XML. So, all right, okay, let's push that. But we'll do that later. All right, let's see, what do we got? We got some commits here. Okay. What's that? All right. Great. Okay, so now that the work is saved, let's push to GitHub. Okay, so git status. What else do we have in here that's not saved? All right, nothing interesting. Well, nothing we need. Okay, so let's see. So yeah, so let's put this in the terminal so we don't have to point tab. And then we can use our docs. And where's this going to go? Right, docs, tutorials, docs, tutorials, Alice, and this would be Alice, and in there would be Alice, and in that directory it would be open source guide. Okay, yeah. So our open source guide, right? RST. Oops. Okay. All right, so we make the directory for it, and then we create the file within the directory, right? So we cat, we pipe. Can you see that? Okay.
Yeah.
Okay. So we use cat, and that basically just says whatever I send to your standard input, we pipe it to a file with bash, and we say, okay, pipe it over to this file, right? So then we paste, let's right click with putty, And now we can do this. Was that rich markdown? Yeah, so this Python library, rich, we can use this. Okay, yeah, it's an RST file, whatever, it's going to interpret it. It'll be fine. So now it'll just dump the markdown for us in a nice little console format. Okay, great, thank you for this. Okay, great. So now we've got this in our terminal for us. All right, great. Now we don't have to switch around. Okay, so what are we going to start with here? So let's go grab, let's see, entities, Alice CLI. All right, so let's jump into here. Let's run an Alice command. So let's do Alice help just to see where she's at. I can't remember if there's any tracebacks in here. All right, so we have should I and threats. All right, so we want please. We want Alice please, because we're going to ask Alice for things nicely. We want Alice to do something. Please do something for us, Alice. Alice, please, CLI. All right, so we just follow the pattern. What did we do? Wait a minute. Produce. Where is this coming from? Alice produce CLI. That's fun. Oh, CLI. Okay, well, that code's dead code. All right, well, we're not going to mess with that right now. All right, so we're subclassing from, we're creating a new CLI command class. When we do that, it basically ends up being another one of these commands over here, right? So Alice should I this is Alice. This is should I goes to should I command. Should I command is, I think, imported, or no, this is should I CLI is right here. So that one has two commands as well. So should I, and then we have -h, and then you'll see contribute, reuse, and use, right? And so those map to those definitions within the class. And then you pointed at, whatever thing you wanted to do, right? And so if one of these classes implements a method named run, then it will run, and it's actually async def run, then it will run the CLI command. And that's where we put the code for the CLI command. So that's just what we're going to do right now. So only we're not going to do it right in there. We're going to create a few more of these because we need Alice please contribute, right? And that is actually all we need. So we just need Alice please contribute. So we have Alice please CLI, and then we have Alice please contribute. All right, so we say contribute equals this thing, and now here we can write contribute. So over here we'll do Alice please contribute, and we'll say help. I haven't saved this file yet. Okay, now I saved the file, so now we'll say Alice please contribute, and it just gives us the help message. Okay, great. And what if we say, if we just run it, then it says feed paste. Okay, great. And so that's what we, over here, we get return feed paste. So now we see that we're executing the code that we're writing. So let's see. So we need, what do we want for this? So Alice, please contribute. So Alice, please contribute. Is this fundamentally about repos? Alice, please contribute. We're running you from the CLI. So when we're running Alice from the CLI, we assume based on the context that this is about a Git repo, right? So let's note that assumption. So note, when running Alice from the CLI, we will, or maybe this is a to-do, right? So when we get that top-level system context in there that we were struggling to get in there with the CLI command unification that we attempted with the system context as a class, once that's ironed out, then when we're doing this, we should facilitate this, reach into the top level system context and infer what we're doing here. And so when this is being called, when this, what is now a class becomes a system context and a data flow, at that point, we'll want to implement the mechanisms to infer, right? So basically this in future work down here, infer context, CWD, right? So if Alice says, where am I being executed from? And she says, what's my top level system context when she runs? So she runs this data flow which just returns feed face, right? Viewing that return statement as if it's a single operation data flow, right? So she's going to say, well, now this is about to do something more interesting with GitHub, and right. And so how does she know that that's what it should do over, how does please contribute not mean maybe, you know, give somebody a donation or something, right? You know, it depends on the context. So if we are in our terminal within a Git repo, we run the data flow, which is Alice, please contribute. We're going to say, okay, we're going to detect, right? And so we're going to have many overlays here, and we're going to have an overlay onto the default flow, which is just this Alice, please contribute, which is this stub, right? And then we have overlays for different environments, right? So when we say Alice, please contribute within the context of speaking to her, it will mean, depending on where you are and what you're doing, it's going to be different than when you say from the terminal, Alice, please contribute, right? Because she says, okay, now I'm in the shell, right? So, okay, so we will inspect the top level system context. When running Alice from the CLI, we will inspect the top level system context in the future applied overlay, which is the Alice, please contribute overlay, which provides CLI functionality or CLI applications, right? So anytime, okay, so it should auto-populate the repos config, or let's see, input required to the data flow, to the base data flow, base repo data flow. Okay. I think that's sufficient, along with the recording. So, all right, so what are we going to do? So we want that blob. So let's go ahead and play with how we would get that blob, right? So read docs portals Alice, Alice. Okay. So here's our content, right? So this is what we want to generate. So let's think about this, right? Let's take the data flow approach to thinking about this. So no paste. This is the list of files. We're going to return to our threads MD in a moment. Okay. So this is what we want. This is the end result that we're looking for, right? So let's do this like test-driven development style. And let's over here start our nodemon, right, which watches for file changes. Let's run the command which we desire be the correct command, right? So we just write this over here, test one. Right, so now, so why do we do the clear? So it clears the screen. We do whatever command we want it to run, and then we want, we just do test one at the end, because or else Bash will complain if the thing blows up. So or nodemon will complain, right? So now we're running feed face. Okay, so let's print this. Just watch it change. Save the file, right? How am I saving the file? There it is. It watched it change. Right, I do escape. I'm in Vim. I do escape. I do colon W, and then I hit enter. Okay, so there we go. So every time we save the file, it changes. So we want this thing. So should be content should be content was. All right, so, and I'm going to use text wrap .edent so that we just get a little cleaner view of that. And I'm going to call strip to, I'm going to call left strip to remove this first new line here that's going to show up. All right, so now we got our nice little clean thing that says content should be, right? And then we say content was, right? So let's now do the same for content was. And so we say, okay, so it's going to be the same right now. And we'll say unit test dot test case dot assert equal, and we'll say content should be, content was, right? And then we'll begin the process of actually generating the content in between. Okay, so we should do that. So we import the modules that we need. We need text wrap and unit test. And okay, so return feed face. Great. Well, that'll be blank. Fantastic. So now let's remove one of the lines and we should see it blow up. All right, so great. It says assertion error. This string does not equal this string, and it gives us a little minus showing that the license was not found. That line was not found. Right. So now we know that our check is working, and that as we start to go about developing our data flow, which implements the population of these fields, we'll know that it's the check is valid. So and then down here we'll say to do implement post to creation of issues now that we once we have body text generation working. Okay, so now here we go. So let's we're gonna take a data flow approach to this, and we're just gonna do a very simple implementation, and we're gonna get that simple implementation, or let's see, yeah, so read, where is that? I think it's in operations inner source. XML operations inner source. Is it in CLI? Yes, it is in CLI. Okay. So, or no, it was in the should I stuff. Yeah. Samples. Should I, and then what's the CLI? Okay. All right, here, we'll just write the functions first. Okay, so basically we say has readme, and it takes a repo object, and then we say, return pathlib. So pathlib is a library, right? So we have to say import pathlib. So we say return pathlib.path, and then repo.directory. We pass these in each as arguments. So we say the first thing, so we're creating this pathlib.path object, and hi doc. Let's see, pathlib. So this is the documentation for the pathlib module. Let's see, where's the top of it? Okay, yeah, so this is the documentation for the pathlib module. So it has these classes here, and so one of them is this path, right? So this is the class that we're about to instantiate, and we do it. We say it has a star args. Basically, what that means is that we're just going to pass in, as many elements to the path as we need, right? So what's the first element of the path? It's the directory. So this is going to end up looking like, if you had a batch variable, this would create the same thing, right? So repo directory slash readme.md, right? So that's basically the equivalent there. And so, but this doing it with this pathlib module allows us to have cross-platform portability between Windows, Linux, and Mac who handle paths differently, really just Windows and Linux and Mac across the Windows divide there. So if this way we can say has README, and then we just say exists, right? And so according to the pathlib module, it has this exists function, and then it tells you whether the path exists, right? And it returns a Boolean value. So if we just call that function right here, then it'll tell us if it exists or not, right? So we just do this for all of our files, right? So we have 5 files, right? And then we can go through and we can check each one, right? And we'll get more advanced, but we'll start out with this, right? So conduct, contributing, license, README, or security. Okay, so, and then these files, right? So it's just rinse and repeat on these, right? So yes, we can use more sophisticated methods and loops and things, but this is just what we're going to do right now because it's just going to help us, take the most straightforward approach, right? Do these files exist, right? Just do the straightforward approach first, right? Okay, so we have these, right? So content should be, we want to run these functions, and we want to get, content was. Okay, and so how are we going to do that? We're going to do async for ctx, results in run, and let's see, we're already in DFML, but we need to input. Okay, so in dfml.run, and then we're going to give it a data flow, right? So we're going to say op imps in, because this is going to give us all our operation implementations. Okay, I'm going to try locals, but I haven't tried this before, so we'll see what happens. So basically, this is going to grab all the local variables where this function is at, right? So set menu. So we're on line 105 right now, and so locals is going to print out, and we'll do it here actually. So from pretty print import pretty print, and then we'll do this. So we'll just print this first. That way we can all see it. Okay, so okay. All right, so this is the local variables at this point, right? So here's has contributing, has license, has README, right? And so it's a dictionary object, right? So I wonder if it'll support this. Let's see. Okay. Okay. So where's this op imps in? So I don't remember how to call this file, so I'm just going to do git rep down here. I'm doing git grep -c op imps in, and we'll just see. Oops. So -c needs, oh yeah, so maybe we want 4 lines of context on either side. Okay, so that's not the name of the function then. Okay, op imp in. Okay, so if we pass this function, so this function here, which comes from dfml dfbase, if we pass it sysmodule's name, so if you pass it something which is an object, it will give you back all these operation implementations that exist within there. So basically anything that has been wrapped with this at dfml.op. And so why is that something that we care about? Well, it's because when you wrap it with dfml op, it says, okay, do basically take this, what is a function that is Python, right, and give me some information about how I might call it. So it's not necessarily, we're moving from this model where we're saying, okay, I call this function this way, you know, this is how I write my code, to more of a way where the call is like a suggestion, right? So so that way then Alice can, based on the intent, knit together the functions in whatever way is most suitable to achieve her end goals, right, for whatever job she's fulfilling. So we're going to annotate them with these decorators. So we say, what is the inputs and what is the outputs, so that she knows, you know, how should she call this thing, because this is what allows us to just say, hey, use the whole lot of these, rather than just tell her specifically how we want her to do it. So, okay, so let's do inputs, repo, and so this is basically this concept of this open architecture, which is this proxy format for domain-specific representations of architecture. And so the functions are Python are a domain-specific representation of architecture, and we're going to use them as they are, but we need to know how to use them. And so we're adding in this what is effectively metadata, right? And then the execution gets based off the metadata by linking it together based off intent is the goal down the road. Okay, so repo is a diffmo feature get dot features dot dot definitions dot get repository. That's probably wrong. All right, read feature get feature definitions get repository. I'm sure I spelled that wrong. Okay, yeah, I spelled it wrong. Okay, so then we'll import that. Okay. And then the outputs, so this will just create a new, so we're in the process of switching things over between a more user-friendly way and a less user-friendly way. So we have not a very, this is not the most user-friendly way to do this. The most user-friendly way to do this is purely with type hints, which are basically to say here, this is the repo, it's of type get, where was that file? It's of type get repository spec. This is a new thing that they've added in Python recently, and it returns new type, which is repo has readme. Which is a bool, right? So this is a much more, basically, this is what we're shooting for here. And this, because this would be this would describe the problem using just a Python type system, which is what we want, right? And so then we would be able to operate off purely the Python type system, and so that way, you wouldn't have to do anything to write a data flow based code versus not data flow based code. All you're doing is writing standard Python code, and you end up with code that you can run in your data flows. So, and it has the type checking and all those guarantees that you want. So, all right, but for now we don't have that. So, I have to finish that stuff first, but pressing matters. Water. All right, sounds good. Pressing matters. Okay, so. Okay. Are we on YouTube still? Okay, we are. Good. All right, so I think we do have the new type support in here. Is it still picking up my voice? Yes, it is. Okay, fantastic, fantastic. Okay, so then the one trick is, once again, you know, we have to encapsulate these in a dictionary, because that's how the implementation works right now. But I think with moving to returning actual input objects from the operation implementation context, this is going to be easier to make this wrapping scheme. If anybody wants to look at the opcode. Okay. Ooh, that feels better. Okay. Results, I'm just going to make it result because that's what it's going to be. Just outputs. Okay, that's not the bug, but and we'll just figure out the thing on that. Outputs. Okay, so we had a missing definitions. I probably spelled wrong. Maybe we just need to import it explicitly. Definition. Diff feature get feature. I'll pimp in. Okay, so once again, we're going to have to just verbose form these as code of conduct. It's so much nicer without the headset. Okay. Code of conduct. I'm sure there's something obvious there that I'm not seeing on how to make this an easier transition for this. All right. So we're just going, easy goes it, copy pasta. I'm just going to figure it out. All right, what do we got? List object has no attribute, export, no retry, run, when dispatch. Okay, let's throw on logging. Somehow we got into a data flow. So we just add dash log debug. All right, there we go. There's our logs. Where the hell are we? All right, so what do we got? Okay, so we're applying overlays. Who came in and asked for a data flow? Who did this? Line 152. What do you have to say for yourself? So you did. Okay. Oh, because this is not a data flow. Looks like okay. Right. So we got what kind of data flow do we have here? Okay, initializing data flow object blank. But okay, so let's do an input, right? So what does our input look like? So repo. Okay, repo. Equals. All right, so what are we doing here? We're going to put it all in one, right? So repo. So repos. So we have a list of repos that we're about to give on the command line, right? So we need something to say, what is this, right? So basically, do I know what kind of repo object this is? Okay, maybe let's just make something that makes a repo object. All right. Result. We're just going to make the object. It doesn't have to be. Inputs. Okay, so what is this input? So I want to make the type engine work. Doesn't it work? Did I have that on here? I didn't push that. Where's that? Let's see. This is just so ugly. All right, let's just make it work first. All right, just make it work first. Okay. Make it work first. Okay. Just do this. No, just forget about this. Forget about this. Just make the get repo spec. Okay. All right, let's see what happens. All right, so all right, self.repo. For repo and self.repos, we have to go give this thing a config. So we say config equals whatever. All right, so I'm gonna do add dfml.config, and we say repos stir equals field dfml.field. Okay, so repos to contribute. All right, inputs, input, give repos spec, not defined. Okay, that also comes from here. So we just throw the input in front of that. All right. Repos. Oh, because it's not a list of strings. Oops. Repos. List string. Oh no, wait, we're not. Okay. All right. So now what happened? Seeding data flow with input set. I recommended community standards also got stuck in there. Okay. Let's see if there's any operation implementations being detected there. Okay, looks like none. Okay, so how do we, why are you not detecting the operation implementations in that? So where's simple namespace? All right, so there's a little trick. All right, there we go. So there's a little trick to my help here. So type simple namespace. So when did they introduce this? Noon 3.3. All right, great. Fantastic. All right, we can use it. Okay, so I think what we really need on this, quite honestly, is that that should work. So okay, iterable, inspect git members. Okay, so here on line 579, we're doing inspect git members to check. So if to check, if not is if So basically, if it's not a dict, then throw it to check. If it is a dict, then run it through this simple namespace conversion, right, to make it into an object. And then yeah, and then you'll be fine. So that's what we just did on the other one. Okay. Are we importing types? No. Okay, so now we're good. We're good there. All right, okay, so now let's run these. All right, now they ran. Okay, so let's see. So it has readme false, has security false. Let's repo directory, recommended community standards, directory. All right, so let's do repos. Okay, so let's actually split these out. So that's not a repos. This is a repos, right? Okay. So let's see, what is our data flow? Okay. So it looks like we're still executing two contexts. Why are you executing another context? Or repo and self.repos. We gave you the dash dash. Why are you getting to? Why? Dash repos. How is she getting? Alright, so the locals there. How is she getting that? Why are you seeing that? Repos list stir. Why? Why are you putting that in there? What happened to dash dash? Don't you respect dash dash? Why is she doing that? What? All right, let's get to the bottom of this. Soft.repos. Why are you in there? Setting repos. All right, the problem, let's commit what we have there. Really? All right, so it looks like there was a formatting thing that we missed at one point, so we have to do that first. All right, so good commit. So we're save where we're at that we know. Df base overlay, or what is this? Op imp ctx. Oh shit. Okay, style format reply. Okay. Base op or mk base in, I guess is the function that we were in. Okay, so build simple namespace when passed, when given picked. Okay, so now we have to go into the fucking CLI command code. Also, util CLI command. All right, so setting repos. Let's run it without. Setting repos. Okay. Field name in KWX and not. So I'm on 181. The field name in KWX and not has attribute self field name setting blank. Okay, so it's setting repos to be this value. So, but why is it doing that? So KWX field name. So why is KWX field name repos in this case? Okay, so we printed out all the arguments that got added. So let's look for repos. Searching with Tmux. Huh. Setting repos equals. Okay. Here it is. Okay, yeah, it's a positional. Okay, here it is. Repos to contribute to. NRX plus. Oh, because I am wrong. Okay. Thank God we don't have to deal with that code. All right. I'd much rather be wrong. All right. I was wrong. So, what's the problem? The problem is that this is asking for a list of repos, and we currently ignore unknown arguments due to the need for all the nested config stuff. We don't enumerate the plugins before load. So, so if we were to enumerate all the plugins prior to instantiating all the CLI commands, we could go through and actually add our parse levels for each one of them, but that would incur huge load time. So we already have large load time. So repos to contribute to. Okay, so this should be, yeah, the default equals none, and then that way it should show up. Okay, yeah, there there we go. So now it's an optional parameter. Result factory. Do that. We'll make a list for us. Okay, so replace this none. Okay, perfect. Okay, that's what I like. All right, great. Okay, so now replace this nothing. Okay. And then, okay. So we'll say, so, okay. How do we do this? I think we do this. Hmm. 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 Oh, I think this is what we found out. Okay, let's wait. Okay. Hmm. Playing with someone. Hmm. with something here. I'm thinking we've got this, we've got that. All right, let's just add CLI command, right? If the event equals that's it. So maybe if the CTF so we do this thing with the context where they have this handle, which you have to call await to get. So as request from CLI. CLI is okay. Okay. So one. Okay. CLI has repos, got an unexpected keyword argument. All right, looks like we got a few outputs here. What do we get? So code of conduct, okay. So no code of conduct, yes contributing, no license, yes readme, yes security. All right, and we've analyzed this repo. Okay. So let's see. So what do we do? CLI is meant on this repo. CLI has repos. Okay. So we just did the inferred, right? Here where we said just recommended community standards. So now we'll do this repos dot, and we should see that we have the same output, but CLI has repos is now outputting you know, the repo object from the CLI, and then the one where we're inferring is not, right? So okay, so we have success. That's pretty fucking exciting. Okay, so let's just go ahead and okay, let's commit. Okay, and let's edit our thing here just so that we get inferred. Great. ls CLI, please contribute infer repos and basic infer repo basic files checks.